Let's consider the following problem. Consider a parallel plate capacitor that is being charged with a current I. What is the displacement current as a function of time? Show the same thing by computing d phi e dt. Alright, well basically for part A, you probably guessed what it is. So the current I is coming in, coming to the parallel capacitor, current I is coming out, and so the displacement current, right, ID is simply equal to I in this case. Right, for part B, this requires a little bit more work, right? So this basically shows the same thing by just working out. So let me consider a parallel plate capacitor. So for a parallel plate capacitor, the parallel plate, you might imagine something looking like this. Okay, there is my E field. Okay, so let's give this parallel plate capacitor an area A, right? And I think that is roughly what I need, right? So basically a current I is coming in, current I is going out, and as a result of there's a Q as a function of time, which is occurring on this charge plate. Okay, so if I use just Gauss's law and draw my surface like this, then basically only on one side of it is important. So basically I got E times A is equal to Q enclosed divided by epsilon 0. All right. Okay. So I could rewrite this as E is equal to basically Q enclosed divided by epsilon naught times A, or divided by A. Yep. Okay. So that is E. Now d phi E dt is equal to basically d by dt of some electric field times the area, really just the derivative of that, right? But in this case, basically electric field is going to be perpendicular to the area, which means it's basically parallel to the normal of the area. So this is just going to be E times A, right? Which you can see is equal to d by dt of Q enclosed divided by epsilon 0 A, okay, times A again. So the A's cancel each other out. So this is just simply going to be 1 epsilon naught dq enclosed dt. But this is just simply I, right? So what we have is that d phi e dt is equal to I over epsilon 0, and I displacement is epsilon 0 d phi e dt. And so this gives me the displacement current is equal to I. All right, hope that was helpful.